boys and girls. So today we are going over Unit 3 review. All right, so we are finishing up the unit. We just want to make sure that we have understood the goal of all of the concepts covered. All right, so as we look here at number 1, it says triangle ABC and triangle DEF are graphed on the set of axes below. And I can see here they are. Part A, describe a sequence of transformations that's going to map triangle ABC onto triangle DEF. Well, anytime I see the keyword sequence, I should be thinking more than one. So I'm just going to box that out and write that down, more than one. And again, I'm seeing that keyword describe. All right, so I have to say it's a reflection over what line. It's a rotation. About what point until, where do I rotate? So I have to make sure that I'm explaining my answer completely. So the first thing that I like to check is going to be the orientation. That's the order of the letters, because that will tell me if a reflection is taking place or not. All right, so as I'm moving from A to B, let me draw an arrow because, again, that's the name of the triangle, A, B, C. So I'm following the order of the letters. Same thing, D, E, D to E because it's D, E, F. I'm going to check. Well, this triangle, it looks like it's turning back time. That would be counterclockwise. And the same thing with this triangle. I'm turning back time. That would also be counterclockwise. So since the orientation is preserved, I know that there are no reflections taking place here. All right. Boom, boom, boom. All right, we got that down. Orientation is preserved. So if I want to describe a sequence, it has to be a rotation and it must be a translation, right? I want these two triangles to map right on top of each other. So I would have to translate one to the other and then rotate around. All right, so I could rotate first and then try to translate after. I like to translate first, get it out of the way, and then the rotation usually becomes a little bit easier to follow with. All right, here we go. If I'm mapping triangle ABC onto DEF, I like to just stack the letters on the side here. And now it becomes very clear that angle A and angle D correspond. So I want to map angle A onto angle D. Well, how am I going to do that? I just have to count the boxes. So it looks like I have to go up, or I have to rise 1, 2, 3, and then I have to go to the right 1, 2, 3, 4. Oops, I miscounted. Let's do that one more time. Looks like I have to go up 4 and over 4. Up 1, 2, 3, 4, over 1, 2, 3, 4. All right, so that's again going to be called a translation because I am just sliding or moving one vertice onto a corresponding vertice. So I'm going to translate up 4 units. And then I'm going to translate to the right 4 units as well. So now I know that A is really on D. All right, I'm going to do the same thing with B and C. Up 4 to the right 4. 1, 2, 3, 4. 1, 2, 3, 4. This is really where B has been moved to. And the same thing with C. Up 1, 2, 3, 4 to the right. 1, 2, 3, 4. And here I am. All right, so with my straight edge, with my ruler here, I'm going to just go back and I'm going to connect these. And again, I'm only redrawing this triangle because it's going to help me visually see what my last and final transformation is going to have to be. All right, so now I can see that if I rotate this triangle 180 degrees, if I just turn it around, it'll be upside down and it'll map right onto DEF. All right, so here we go. That's my last step. It is a rotation. And anytime I rotate, I have to rotate about a center. So I'm going to say I'm rotating about point A. All right, you're moving your pre-image ABC onto DEF. So I have to pick A, B, or C as my center, but it has to be A, all right, because I'm rotating around A. It is on D. And then I want to rotate because I want C to map onto F. I want B to map onto E. How am I going to have that happen for me? If I rotate 180 degrees. All right, because I am on the coordinate plane, I want to make sure that I am using a degree measure. And then part B, it says describe a single transformation that's going to map triangle ABC onto DEF. All right, now be really careful. Part A said a sequence, so I had to pick more than one. So anytime I get a rotation, I always just translate as well. So that way I get a sequence. I have more than one. I could have just rotated. Let's write this down. I could have just rotated 180 degrees from the start about the origin. And triangle ABC would have mapped onto DEF. So here we go. I'm going to put my pencil on the origin, and then I'm just going to, again, rotate 180 degrees. That means my paper will be upside down. All right? I can see that triangle, here we go, DEF is in quadrant 3, and again, if I rotate back, that's originally where triangle ABC was. It was in quadrant 3. All right, so I know that if I rotate 180, that's definitely going to work out, but that wouldn't have been a sequence. All right, so again, that's why anytime I rotate, I like to do the translation first. Because if I had just rotated, that would have been one transformation, and that wouldn't have been enough. All right, and just FYI, this is how I am seeing how to solve part A. That's the hard part about geometry. There's always more than one method when you're solving here. So I could have done 2 reflections. All right, because even though orientation is preserved, let's say I reflect over the X, whoop, now my orientation is reversed, but then when I reflect over the Y, whoop, then it was flipped back. All right, so you could have done 2 reflections. Reflect over the X, then reflect over the Y as well. All right, there could have been even more transformations, more sequences, all right, but that's just what I'm seeing for this question. All right, let's look at number 2. It says, in the diagram below, congruent figures 1, 2, and 3 are drawn. Congruent means equal, so I'm just going to highlight that. Describe a sequence. Again, sequence means more than one. A sequence of transformations that's going to map figure 1 onto figure 2, right, and then onto figure 3. Okay, so here we go. As I'm looking from figure 1 to figure 2, I can see that this is just going to be a translation because nothing about those shapes has changed except the position, where they are. So I can see A to B, right? That's moving again clockwise, and A prime to B prime is also moving clockwise. So that means that orientation, again, just like in number 1, orientation is preserved. So I know there's no reflection. It has to be a rotation or a translation, but again, it's definitely a translation, all right? So when I translate, here we go, translation, I would normally say I'm translating, 4 units up, 3 units to the right, just like we did up top, because we were on the coordinate plane. But in number 2, I am not on the coordinate plane, so I have to use array. So I'm going to connect corresponding points. I'm going to pick D and D prime, all right? You guys can pick A and A prime, C and C prime, E and E prime, it doesn't matter. All right, but you have to pick one ray to translate along. And again, I'm going to pick D, D prime. So I'm going to say this is a translation along ray D, D prime. All right, so now I've moved from 1 to 2. How do I get from 2 to 3? So here we go. How do I get from A double to B double? Well, that's still rotating clockwise. This was clockwise, this was clockwise, this is clockwise, all right? So I know that this would not have been a reflection. Some of you might have already been able to see that, so it is definitely a rotation. But again, when you rotate, right, if we're on the coordinate plane, I like to use a degree measure, but again, number 2, we are not on the coordinate plane. So that means I have to find the center of rotation, and we do that by making 2 perpendicular bisectors, and where they cross is your center. I'm going to press pause, all right, because I want you guys to connect 2 corresponding points, make 2 footballs, those 2 perpendicular bisectors, and you find the center of rotation, and I'll do it as well. All right, so here we go. I decided to connect B prime and B double prime, and I made a perpendicular bisector in pink. When I was done, I highlighted out that perpendicular bisector. I also connected C prime and C double prime, and then made another perpendicular bisector in purple, and then again highlighted out that line in yellow, just because it becomes very clear then to me, oh, that's where my highlighters are crossing, so that has to be my center of rotation, and I have to give it a letter, so I'm going to pick O, because O is not being used in any of these diagrams. All right, so here we go. I'm going to say it's a rotation. I have to say what my center of rotation is, so I'm going to say it's a rotation about point O. And now this is going to be a little bit different because since I'm not on the coordinate plane like up top, I don't know how many degrees I have to turn to get from 2 to 3? It looks like 90, but I'm not sure. So I'm going to say, because I'm not on the coordinate plane, it's a rotation about point O until angle, and I just have to pick one pair of corresponding angles. So I'm going to pick angle B prime and angle B double prime. So I'm going to rotate until angle B prime maps onto angle B double prime. All right. Let's look at number 3. Which transformation is not a rigid motion, and explain why? I want you guys to try that one on your own. Okay, there's 4 transformations: reflection, rotation, translation, and dilation. All right, so out of those 4 transformations, which is not a rigid motion and why? All right, it's going to be a dilation. All right, we know that dilations can change the size. So again, why is it a dilation? You have to use vocabulary, because the side length or the distance, you could have also said because the segments, all right, are not preserved. Awesome. And then number 4, it says, as graphed on the set of axes, triangle A prime, B prime, C prime is the image of triangle ABC. Describe the sequence of rigid motions that's going to take triangle ABC to triangle A prime, B prime, C prime. Again, I'm seeing describe a sequence, but this time they're telling me the sequence is going to be rigid motions. So I know I have to pick from reflection, rotation, and translation. All right, sequence is more than one. So I know I got to first check, like always, what's the orientation? So I'm going to follow the order of the letters, A to B, and then A prime to B prime. So A to B, I'm moving like a clock, so I'm going to say that's clockwise. A prime to B prime, I'm turning back time here, I'm going to say that is counterclockwise. So since orientation is not preserved, I know that some type of reflection had to have taken place. So that's the first thing that I'm going to do, and I'm going to write that down just to get it out of the way. So I'm going to say that first I'm going to reflect. Well, if I'm getting ABC over to A prime, B prime, C prime, I'm thinking that I have to reflect over some type of vertical line here. All right, if I look carefully, I can see that that vertical line is going to be the y-axis. Because if I start counting boxes, since that's how we've learned how to reflect, if I go 1, 2, 3 to the right, I know that it's not in the same spot yet, but if I go 3 to the left, I get A prime as well. All right, if I go 1, 2, 3, 4 to the right for B, 4 to the left, I get B prime. All right, so I know that a reflection is equidistant. Those corresponding points are the same distance away from that line of reflection. So this is definitely it. It's a reflection over the y-axis. And then just like in number 1, I'm going to actually reflect now. So instead of 3 to the right, I'm going to go 1, 2, 3 to the left. This is where A would be after I reflect. Same thing, instead of 4 to the right, I'm going to go 4 to the left. And this is where B would have been after I reflect. And then again, instead of 1 to the right, it's going to be 1 to the left. This is where C would have been after I reflected. Now I'm going to go back with my handy dandy straight edge here, and I'm going to connect to form where that reflected triangle would have been. And now it becomes very simple, very clear for me to see, well, if I just slide B down, A down, and C down, it'll map onto A prime, B prime, C prime. Well, a slide or a move is a translation. I'm on the coordinate plane, so I just count the boxes. Well, if I translate 3 units down, 1, 2, 3, I know that my corresponding points will match up. So it's a translation, 3 units down. And then I got my pre-image mapping onto my image. All right, I'll meet you on the next page. All right, number 5, it says the image of triangle ABC after a rotation of 90 degrees clockwise about the origin is triangle DEF. Which statement is true? All right, I want you guys to try this one on your own, but before you do, let's talk about some important information, okay? I know that a rotation, all right, no matter where I'm rotating, is a rigid motion. I know this sounds silly, but I want you guys to box this, and I want you to actually write that this is a rigid motion. All right, and what do we know about rigid motions? They preserve, or they keep the same side length and angle measure. All right, so I know these two triangles are congruent. They're the exact same triangle. It's just that one is in the first quadrant and one is in the fourth quadrant because there was a rotation that took place. all right? So when it says which statement is true, it looks like I'm identifying corresponding parts here, okay, in both triangles. And when I'm looking for corresponding parts, you guys learned a really quick trick. You just stack the letters. So I'm going to follow the order of this triangle, which is A, B, C, and then I'm going to follow the order of the next triangle, D, E, F. And now it becomes very clear that angle A and D correspond. Same thing, line segment AC and line segment DF correspond. All right, first and last, first and last. All right, so use this trick, and I want you to see if you can follow out number 5 on your own. All right, here we go. Number 5, it should have been choice 4. All right, so whatever is easier for you guys to do. I like to just usually look at it as the letters are stacked up top, but if it's easier for you to actually rewrite it out, guys, whatever you got to do to get that correct answer, please do that. All right, so I know that angle A corresponds with angle D because they both come first when I am naming the triangles. It is choice 4. All right, number 6. It says triangle ABC is graphed on the set of axes. Graph and label triangle A prime, B prime, C prime, the image of triangle ABC, after a reflection over the line y equals -1. All right, so there's a couple of important things here that I'm seeing as I read this question. Let me grab my highlighter here. If I want to graph and label triangle A prime, B prime, C prime, it's telling me in order to get that new triangle, right, the definition of image is new. That means that I'm going to take triangle ABC and I'm going to reflect that triangle over the line y equals -1. So I'm going to highlight that out as well. Now I'm going to have to go ahead and graph that line y equals -1. So if you guys don't know where it's going to be, if you have that graphing calculator app on your phone, or if you have a graphing calculator at home, or even when you guys are in school, you would just turn it on, go to the y equal, and you could just type in y equals -1 graph. And now you can clearly see that it's going to be this horizontal line hitting -1 on the y-axis. All right, so here we go. I'm going to just grab my ruler here, and I'm going to draw that line, y equals -1. All right, I know lines go on forever. I'm going to add arrows on both sides. Y equals -1. I'm going to label it. And then you guys know that whenever we reflect, we like to highlight that line of reflection so it becomes very clear where I'm reflecting over. All right, so from that line of reflection, instead of going up 1 unit for A, I'm going to go down 1 unit for A prime. All right, same thing for C. Instead of going up 1, I'm going to go down 1 for C prime. And then from the line of reflection, I have to count up 1, 2, 3, 4, 5 for B. So from the line of reflection, I have to count 1, 2, 3, 4, 5 down for B prime. All right, when I reflect, I should be getting a triangle back. So with my straight edge here, I'm going to go and just draw that in. All right, all it asked me to do was graph and label. I graphed, boom, I labeled, done. All right, let's look here at number 7. Number 7 says triangle ABC is graphed on the set of axes. Part A, graph and label triangle A prime, B prime, C prime, the image of triangle ABC after a reflection in the line x equals -3. So again, I'm going to highlight out what's important. I have to graph and label that prime triangle. I'm going to get that new triangle by using ABC to do it. Okay, and then again, the line of reflection is going to be x equals -3. So if you look back at our question from up top, I know that if it's a y equal, it's going to be a horizontal line. All right, and we can always type that in the calculator. If it's an x equal, that would be a vertical line, straight up and down. All right, but I don't have an x equal on my graphing calculator, so you got to have that memorized here. So on the x-axis, where is x equaling -3? From the origin, I'm going to go 3 to the left. 1, 2, 3, here it is. But I'm also -3 in all of these spots. All right, so this is the line that I'm going to draw in. Let me grab my straight edge here. Straight up and down, lines go on forever. I'm going to just quickly label it. This is the line x equals -3. And then just like before, I'm going to highlight out that line, and I'm going to reflect over it. All right, I want you guys to finish reflecting this section on your own and then check back. All right, so after we reflect, this is where triangle A, B prime, C prime would be located. Notice how I only said B and C have a prime, A did not. So as we look at part B, it says what happened to point A? I'm going to say absolutely nothing happened to point A. All right, A is on the line of reflection, so I can't count boxes to move it. It just stays in that one spot. So I'm going to say nothing because it is on the line of reflection. All right, boom. Let's look at number 8. It says fill in the blanks on the properties of rigid motions. Rigid motions preserve what of segments? Well, it preserves the length of segments. All right, and what else does it preserve? It also preserves the measure of angles. All right, meet you on the next page. All right, as we look at number 9, it says describe the rigid motion that's going to map A, B, C, D, E, F onto A prime, B prime, C prime, D prime, E prime, F prime. Okay, so the first thing that I always like to do is just check that orientation. So I'm going to star that and write it up here at the top. Orientation is, all right? So is orientation preserved or is it not preserved? All right, so let's check. If I follow the order of the letters from A to B, let me draw a little arrow here from A to B. I'm going to do the same thing from A prime to B prime. All right, I can see that this moves like a clock. So this is moving clockwise. All right, and if I look at my image here, this is also moving like a clock. This is also clockwise. So orientation is preserved. So that means there is no reflection taking place. So when I want to describe what that rigid motion is going to be, it's not a translation. A translation just moves or slides something. And if I take this pre-image and just slide them down, those guys are definitely not going to map onto each other. So this has to be a rotation. All right, so when I rotate, I have to find the center of rotation. And I also have to say where I'm rotating until. All right, I want you guys to find the center of rotation by creating 2 perpendicular bisectors and seeing where they cross, and then we'll finish this one up together. All right, here we go. After you create those perpendicular bisectors, and I highlighted them out just so it's clear for me to see, I know that they cross right here, and I labeled it with point O because O is not a letter that's being used in this diagram. All right, so let's finish this out. I know that this is a rotation. The center is point O, so I'm going to say it's a rotation about point O. And since I'm not on the coordinate plane, I'm not going to say it's a rotation of 180 degrees or 60 degrees. I'm going to say it's a rotation about point O until, and I just have to pick one pair of corresponding angles that will map one onto the other. So I'm going to say until angle A maps onto angle A prime, because again, I know they correspond. All right, that was number 9. As we look here at number 10, it says complete the table. So they're giving you directions on how you're going to rotate these 3 letters, and you have to come up with the image. All right, try this question on your own, and then check back for the answer in a minute. All right, here's number 10. This is what you should have got. So when you first rotate, I know that all of these guys say that I'm rotating about its center. So that's going to be the center of the letter. All right, so when I rotate 90 degrees counterclockwise, I know that's 1 turn. Counter means I'm turning back time, so 1 turn to the left. And then when I translate, a translate is just a slide. I am moving it over. All right, same thing, rotating 180. 180 is 2 turns. And then again, I'm translating it to the right, translating it over. Last but not least, clockwise would be forward in time. So that would be to the right, 1 turn, right? 90 degrees is 1 turn. So I'm dropping this J over and then again sliding it to the right. All right, let's look at number 11. It says in the diagram provided, what rigid motion or rigid motions is going to map segment CD onto segment AB? All right, so again, I like to just follow the order of the letters here so that way I can see what's happening. So I'm going to just go in alphabetical order here. So as I move from A to B, I can see that this is moving clockwise. And as I'm moving C to D, again, just following the order of the letters, A to B, C to D, I can see this is also moving clockwise. So I know that there is no reflection taking place because, again, orientation, the order of the letters is preserved. All right, so it has to be a rotation that's taking place. So if I'm rotating, I know that I want to rotate right around that middle point here, because if I hold my pencil in place and turn my paper, triangle ABC was in the top left. So now when I rotate my paper around, triangle BCD is now in the top left. All right, so I know that 180 just gets me flipped right across. So here we go. Whoop, let me turn it back. All right. So what is this point called on segment CD? Well, if it's right in the middle, it would be called a midpoint. So this is going to be a rotation about the midpoint of segment DB. And again, I'm going to rotate until, because I don't know how many degrees exactly. It looks like it's 180, but just in case, I'm going to say I'm rotating until angle A maps onto angle C. Again, A comes first, C comes first, so I know they correspond. All right, meet you on the last page. All right, as we look at number 12, it says, what is going to be the angle of rotation that is going to carry that regular polygon onto itself? Well, I know that a regular polygon, that's a huge vocabulary word. Regular polygon means that all the sides and all the angles are equal. So let's highlight and box that out. Equal sides and equal angles. So if I have a 5-sided shape that all sides are equal, that would be a pentagon. So this is that formula we had learned. You're going to take 360 for a full circle if I rotate it all the way, divide it by the number of sides, and you get 72 degrees. So I know that to get from one side to the next when I turn, that would be 72 degrees. But I can't just turn it one time. I could turn it 5 times. So this is all 5 rotations. I can see 216 matches. That's how I'm getting choice 3. And number 13 was fairly straightforward. Again, to translate just means to move. So I'm just counting the boxes, up 1, to the right 2, and then I made sure that I labeled, let's highlight that. I want to label triangle, D prime, E prime, F prime at the end. So make sure that you form that triangle once you are done. All right, 14, I want you guys to try on your own, and I'm just going to show you the answer in a quick minute. All right, so do your best, take your time, show all your work, all right, and then check back. All right, guys, here's the answer to 14. Make sure again that you are taking your time carefully reading each question. I know that some of these might have looked a little bit tricky. You really need to find those key words and break it down. So again, make sure you are carefully going through number 14. If you have any questions or need any help, please message us on Canvas and we will go from there. All right, have a great day.